Yeah, so that was geometry-based trajectory mining, just a glance, as I said before. And the next will be some ideas for semantic-based trajectory mining. One also pioneering work which made clear that you not only need to consider spatial trajectories, but also just conceptual trajectories, is the work from 2008 by an Italian guy. So trajectories in a spatial temporal object is a spatial temporal object that has some generic features which can be, or which are typically independent of the application, and some semantic features, which is, of course, as we said before, dependent on the application. And a trajectory can also be just a travel in an abstract space, need not to be a spatial space, of GPS coordinates or something. So, for example, here it is a travel in a 2D career space. So one is, of course, again the time, and one axis now here is the position a person had at a given time slot or a given time interval, and at which institution. So, for example, this person was an assistant in Paris for a given time interval, and then he or she moved to Paris, or not moved really, just had a different position, but at the same institution, and then the person moved to Dijon and also changed the position, and kept the position then, but moved to Lausanne, and finally terminated the career or whatever. So and that is a conceptual space now, obviously, which is different than a classical spatial space. So semantic trajectories are typically just spatial trajectories enriched with semantics. So you have trajectory samples, you have geographic data, you have semantics data, conceptual data, and if you enrich this geographic data, this is called, so this is application specific, and this is called geographic data. If you enrich both or combine both, you end up in semantic trajectories. So you give meaning to the trajectories. That's actually the idea, that for example, this here is the Eiffel Tower, and that is the park in front of the Eiffel Tower and stuff like that. Okay. And the key challenge here, if you want to mine semantic trajectories, is the differentiation between stops and moves. So there's a lot of work about how to differentiate between stops and moves. So when does a trajectory stop at a given point of interest, which has a clear semantics, and when does the trajectory just moves between two of those region of interest or points of interest. So stops are obviously important, the important parts of the trajectories, where the moving object has stayed for a minimal amount of time. Stops are of course application dependent. For example, in tourism application, it's hotels, touristic places, airport, whatever, so transportation. In traffic management applications, it's more concerned about traffic lights, roundabouts, big events maybe, or stuff like that, flash mobs or something like that. So application specific, the important parts, and moves are just all the other parts of the trajectories that are not stops. So the stops are the real important things to find, actually. And before we talk about that, stops and moves are can also be independent of the application. So in that case, here you see this one here is or you can try to come to compute stops and moves independent of the application, and then give those stops and moves some meaning, and that is again dependent on the application. So that is a little contradicting to this one here. So the semantics of the stops are applications dependent. but not the stops itself. Yeah, so that is the point. So stops and moves are independent of the definition of and the finding of stops and moves are independent of the application. The meaning of stops, of course, are then dependent of the application. Yeah. So here you see a trajectory, and probably this one here is a stop. This one here is a stop. This maybe, and this one here probably a stop. And if you then give or have a look at tourism application, you see here, this is the airport. This is not an important stop for the tourism application, but this one here again is an hotel. This is the Louvre. This is the Eiffel Tower, whatever. Yeah? And from another different view, traffic management view, airport is also interesting. This one here is a roundabout. This one here is a traffic jam. This is not interesting because it's a hotel. This is a crossroad here, but we cannot find it. But anyway, so the Louvre and the Eiffel Tower is probably not so interesting from a traffic management point of view. Yeah, so you see here that again the stops and moves are independent, but the meaning of the stops and moves are application dependent, of course. Yeah, and how to enrich. Oh, no, I'm sorry. And geometric patterns can also be just enriched by semantics. So you just try to come up with geometric patterns as before in the first class of approaches, and then enrich them by semantics. Since we have very little semantics in most trajectory mining approaches, so in the geometric based approaches, the patterns are purely geometrical and hard to interpret. So in that case, we need to enrich the geometric patterns with semantic information, and that has been stated in 08 already, and that stimulated many approaches on how to add semantics to trajectories. So just that you know that there are just a plethora of approaches on how to use geometry-based approaches first to come up with some kind of geometric patterns, and then enrich them by application-specific semantics. So here's an example for an enrichment. So this is a geometric pattern like encounter or stuff like that. Yeah, and then if you add semantics to, for example, the start points of each of the trajectories and the end point of each of the trajectories, which and the region of the encounter, where the encounter took place, then you see, okay, the encounter took place in the city center, and T1 and T2 came from a specific hotel, T3 came from a specific hotel, T4 came from somewhere, maybe from some suburb. So this may be a local, and the other guys may be some tourists. And you see that some of those guys went to restaurants, where others went to some cinemas. Yeah? So in that case, you compute, as I said before, a geometric pattern, as we discussed before, and then you enrich those patterns by trying to give some meaning to start points, end points, the regions that feature the geometric pattern. Remember that those spacing patterns, geometric patterns by Laube et al. Always are involved always involve a region where the patterns actually happen. So you can also try to give this region, of course, the semantics.